We're on lesson 7.8, which is factoring polynomials completely. So today we're actually going to discuss a new concept that we actually discussed previously, briefly, when we were trying to figure out when we didn't have a equal to and the whole notion of ax squared plus bx plus c equaling to 0, or even if it wasn't equal to 0. This coefficient a, when it wasn't equal to 1, we had an issue when the coefficient wasn't equal to a, or excuse me, coefficient a wasn't equal to 1 with actually factoring these. So we're going to do what's called factoring by grouping, which is part of the method that we had used previously. I want to just, again, discuss something before we get into factoring with grouping. If we say that a, b plus a, c, right? And we are going to go here and factor this guy out. We're going to effectively undistribute this. So we're going to factor out the a. And then what we're left with is b plus c. If I redistribute those, I get ab plus ac. So here is my rule. I'm going to effectively factor out something, and whatever I have left over gets grouped together. So let's remember this concept as we go through each of these. What we have done so far is we have done second degree polynomials. And here we have a third degree polynomial. Question has been, how do we actually go about factoring this without really just like guessing at it? I mean, this is where it gets pretty tricky. How do we factor this, right? Well, this doesn't cleanly factor just into, it's not like just this problem where we had x squared plus 5x plus 6, right? This right here was a second degree polynomial. It's a trinomial that would turn itself into two binomials, right? X and x, since we had a coefficient for the a term right here that's 1. So we just know it's going to be x and x. It's going to be positive and positive because it's going to be two factors of positive 6 that yield a positive 5, right? So both positive numbers, and the answers are 2 and 3. Okay, straightforward. But how do we actually go about doing this? Well, here's what we do. We're going to take this original. I am not going to touch it. I'm going to rewrite the entire thing just so we know what our original polynomial was. And I'm going to group together the first two terms and the last two terms. But notice this guy in the middle, that sign, I'm actually not going to deal with, okay? I'm going to make sure it's not grouped within the terms. So I'm going to add the first two terms to the second two terms. I'm going to see what I can factor out for both terms. If I get something matching in between, it's just like if I had the leftovers, b and c, because what I had technically matching was the a, okay, from the, just like undoing the distributive property. So in other words, let's do this. Factor out what comes out of x to the third plus 3x squared. Well, we can take an x squared out of both terms. If you divide x to the third by x squared, you're left with an x, and you pull out the x squared, right? So x squared divided by x squared is just 1, and we're just left with the 3, okay? If you multiply back just to check, right, you'll get x to the third plus 3x squared, which was our original thing right here. So moving on, adding. Now what can we pull out of both of these two terms, 2x and 6? Well, we can take out a positive 2, correct? So we'll pull out a 2. 2x divided by 2 is just going to be an x, and plus 6 divided by 2 is going to be a 3. This matches and this matches, so we're going to factor this out. Here I have x plus 3, okay? And again, remember what we did back up here. When a and a matched, we factored it out and we left and grouped b plus c. So what's left over is we have x squared plus 2, and that is the remaining portion that I'm going to factor out. Now we're going to check here, can we factor x squared plus 2? And the answer is no, right? Because we have an x squared, we have a binomial that's a second degree function. The only way we know how right now to factor that is if it's a difference of 2 squares, right? And if this were like a minus a square number, then we could continue factoring. And sometimes we'll be able to. All right. Let's now try another four-termed polynomial and see what it yields here when we do factoring by grouping. Let's do x squared plus 4y plus 2x plus 2xy. Maybe it helps to see it this way, just one more time to review. Remember when I did AB plus AC and I factor out the A? What if I wrote it as BA plus CA, right? That's the same thing, correct? Commutative property. And I can pull out the A, right? So you then get B plus C grouped together. That's what I'm doing here. Maybe that helps you to see it the other way around. So again, coming over here, I'm going to group these two. Oh, sorry. You know what I failed to do? Let's actually rewrite it one time so we can leave our original clean. When you go back in your notes and see what in the world it was that you were doing. When you're actually doing these problems, you're operating on them straight, it's okay if you actually just write it down and start working on it. But I want to make sure that your notes make sense. So again, parentheses around each of these two terms. And right now, I can't really factor anything out. So let's rewrite this in terms of the commutative property. Now, if these guys were switched here, and I had a 2x here and a 4y here to group, could I then group off individual terms? Can I do that? And the answer is yes, right? When I saw that I have an x squared and a 2x here, I could see that an x could be pulled out of both of those terms. And we'll see something matches when in the parentheses once we actually start doing that. So when I pull an x out of x squared, we get an x, and I pull an x out of 2x, we're left with 2. Okay? Still adding. And then we see what we can pull out of both of these. Now there's a y that can get pulled out of both, but there's also a 2. So a 2y can come out of both of these guys, right? And let's see what happens. 4y divided by 2y is just 2. And 2xy divided by 2y is just going to leave me with an x. Gentlemen, this and this absolutely match. Maybe it would help you if you saw it this way. X plus 2 is 2y. And again, the commutative property, meaning that we can actually switch around the order of our terms the same way that we did way back up here, right? That's fine. It's totally allowed. This and this match, so we factor it out. And then we're going to group our leftovers, x plus 2y. That is what we're left with. Neither of those can be factored out anymore. Nothing can be pulled out of both. So that is our simplest factored form from that original four-term polynomial. Continuing on. Let's take something that looked a little bit like our original example. X to the third plus 4x squared plus 2x plus 8. Only dealing with one variable. So when I come here to start grouping it, it's in standard form. Since I only have one variable, I'm probably going to be in good shape if I attempt to factor by grouping, that it's probably going to be effective, right? If it can be factored at all. Sometimes it can't be. We've just been lucky so far, and it looks like we're going to be okay here. It looks like there's going to be terms, or there's going to be factors that are going to come out of both of those binomials for each of these individual four terms. So for the first one, we're going to pull out is just going to be an x squared, right? X to the third divided by x squared. We pull out an x squared, and we're left with just an x. Pulling out an x squared from a 4x squared, right? So in other words, divide 4x squared by x squared, and we're left with a 4. Plus, I have 2x plus 8, I can pull out a 2. What am I left with? I'm left with x plus 4 in there. Matches, therefore, that's what I'm going to factor out. I group my leftovers, and I'm done. All right, let's keep going. 2x to the third plus 6x squared minus 2x. Now, before I get going, I have a trinomial. So let's see what I can factor. And what we did before is we factored, hey, we've got a factor for each that can come out both in terms of the coefficients and then the variable portion of the term, just the x. Something can come out of every single one of those terms, right? So let's pare this thing down. I can actually factor out a 2x before I start. All three of those terms can be divided by 2x. So 2x to the third divided by 2x is going to be x squared. 6x squared divided by 2x is going to be 6 divided by 2 is 3. X squared divided by x is x. And then 2x divided by 2x, or negative 2x, we're going to have a negative 1 here. This trinomial is one of those that we can't factor. There's going to be no binomial here, right? It's going to be an x and x. I'm looking for, again, a plus and a minus, right? Because that's the only way you're going to get the product of two things become negative. One's going to be positive, one's going to be negative. Nothing is going to be that for 1, because the only factors for 1 are 1, right? The only way that we're going to come up with that, there's just no way we're going to come up with that with having a sum of 3, right? Of any of the factors of 1, right? Just 2 factors, that is. So this can't be factored. What does that mean? It means we actually can't factor anymore. We've already factored a 2x. It means we're done, okay? So that one's pretty straightforward. Let's see what else. Sometimes we can keep going. Let's try a 4th degree one. Uh-oh. All right. Well, what can get factored out of 5x to the 4th and negative 45x squared? Well, I think we can take a 5 out of 5 and 45, right? And we can take an x squared out of x to the 4th and x squared. Let's see what we're left with. We have an x squared, right? 5x to the 4th divided by 5x squared is going to be x squared. Negative 45x squared divided by x squared is going to be a negative 9. Gentlemen, we have to keep going, right? Watch. I have a 5x squared, and take a look from last night's assignment. Look what I have here. This is a difference of 2 squares, right? I have x and x. It's a plus and a minus. It's only 2 terms for a 2nd degree polynomial, and both are squares. X squared has a square root of x, and 9 has a square root of 3. So plus 3 minus 3. This is our factorization here. Sometimes we can just keep going. All right. And then how that affects us solving various problems here, okay? Let's give it a shot. Let's say we have to solve 3x to the 3rd plus 6x squared equal to 24x. We're going to see how this works. Ready? Let's move this guy over, okay? So as we start, we're going to subtract 24x from both sides. Why? Because remember, the base quadratic is going to be ax squared plus bx plus c all equal to 0. That's the basic quadratic equation that we're going to work with, okay? So rewriting this guy, 3x squared to the 3rd plus 6x squared. I'm going to go in descending degree minus 24x, and it's all equal to 0. Question is, what can I factor out of all of those terms? Looks like a 3 can come out of all those coefficients, right? 3 divided by 3, 6 divided by 3, 24 divided by 3. I can also pull out an x, a single x, out of x to the 3rd, x squared, and x, okay? And then now, I've pulled out a 3x from 3x to the 3rd, and that's going to be x squared. I divide 6x squared by 3x, and I get 2x. And I can divide a negative 24x by 3x, and I'm going to get a negative 8. All still equal to 0. Perhaps this can be factored, and it can be, right? X and x. I need 2 factors of negative 8. They're going to get me a positive 2. And it's going to be a positive 4 and a negative 2, right? Just to double check, outer, inner. right? 4x minus 2x is going to be positive 2x. That's exactly how we do it. So now we have three problems, all equal to 0. 3x is equal to 0, x plus 4 is equal to 0, and x minus 2 is equal to 0. Three things to solve. First one is a quick one. It's going to be 0. Divided both things by 3. 0 divided by 3 is 0. Subtract 4 from both sides. X is going to be negative 4, right? And of course, the last one, we're going to add 2 to both sides. So x is going to be 2. So those are my three solutions for that problem. All right. We have a box. Comes from Amazon, which has a volume of 96 cubic inches. The length is expressed as x plus 8 inches. The width as x inches, and the height as x minus 2 inches. Find the dimensions of the box. All right. For volume, for a box which is a rectangular prism, and we'll go over this in geometry next year, so those of you who are blessed enough to have me again, volume is going to be equal to the length times the width times the height. Technically, it's equal to the area of the base times the height. And here, that base being a rectangle, right, is going to be the length times the width. So, what they gave us to start was that my volume is equal to 96. And now I'm just going to be putting in each of these things. Again, L is equal to x plus 8. So I have that. Then I have my width, right, which is going to be x. Okay. And then I'm going to have my height, which is x minus 2. So those three things are substituted in for those three variables. All right. I got to actually multiply this guy out. So I have 96 is equal to, and I'm going to go ahead and distribute this guy into here. So I have x squared plus 8x. Okay. And then that's going to still be multiplied times x minus 2. All right. So we got to continue to solve. Ready? We're going to go FOIL first, outer, inner, last. So 96 will be equal to x squared times x is x to the third. X squared times negative 2x is negative, x squared times negative 2 is negative 2x squared. 8x times x is 8x squared. And then 8x times negative 2 is negative 16x. We have a little bit of algebra to do here, right? So we have 96 is equal to x to the third. When you combine negative 2x and positive 8x, it's going to give me 6x squared minus 16x. I'm sorry, this was not x to the third squared, it's x to the third. My bad. I need to rewrite that properly. Now remember, in order for us to solve these, we need to eliminate this and make it equal to 0. So let's go ahead and subtract that off. I'm going to subtract 96 from both sides, which will give me x to the third plus 6x squared minus 16x minus 96. All right, this is effectively my problem. Now, this takes me in, let's just forget about the equals 0 thing. If we take this back to the very first part of class today, what I have is 0 is equal to, right, this 4-term polynomial that I can group together. Now be careful what happens here. Watch. When I group this, it's going to change my sign. Oops, not that. It's going to change my sign, and this is going to become now a positive 96. We went over this before when we did some factoring while grouping with a different problem earlier, but just be careful. Whenever you group off a negative, when you're doing factoring by grouping, remember, this negative still has to make sense in the original problem. What happens if I distribute it? Negative times, right, like a -1. Let me write this a little bit clearer for us. There's our negative, and then here's our parentheses. Okay, if I have a negative, it's like a -1. And -1 times the 16x is going to give me -16x. The negative times positive 96 will give me a -96. If I don't change that sign, it's not going to make sense for that last term, okay? Now, let's start factoring. I can factor out an x squared from both of these terms, right? Factor out an x squared from x to the third, I have x. Factor out an x squared from positive 6x squared, I have just positive 6. And what can get factored out in the next portion? Well, looks like I can take out from 16 and 96 that I can pull out a 16. So I now have a -16 outside, right? If I have that 16x divided by 16, it leaves me with just x. And then 96 divided by 16 is positive 6. So now look what I have. These guys match. 0 is going to be equal to x squared minus, x plus 6, and it's going to be x squared minus 16. Keep factoring. I have an x plus 6 still. I have a difference of 2 squares with x squared minus 16. What was our lesson before? So x and x, plus and minus. Square root of x squared is x. Square root of 16 is 4 and -4. All of those things are equal to 0, right? So I have an x plus 6 equals 0. I have an x plus 4 is equal to 0. And I have an x minus 4 equal to 0, right? Watch what happens. -6 minus 6, x is equal to -6. -4 minus 4, x is equal to -4. And then plus 4 plus 4, x is equal to 4. Now I have 4 answers here, but watch. These are trash. These are extraneous answers. How do I know that? Because this has to make sense in our original problem. Okay, let's go back. What does this even mean? Well, x is your width. If you can show me a box that has a width of -6 inches, I'll pay you an extraordinary amount of money, okay? Like if you actually can bring one of those to my class. Same thing, show me one that has that's -4 inches. A box that has a width of -4 inches. Those answers don't make sense. So right here, the 4 is going to be our width. Again, let's take this. I'm going to bring it back up here, okay? And if x is now equal to 4, that's our width. Length is going to be equal to 4 plus 8, right? Or 12 inches. And then the height is going to be 4 minus 2, which is 2 inches. And those are your dimensions of your box. If you have any questions, go ahead and feel free to reach out to me on Canvas or through email. Good luck.